I'm going to go through the questions in the order that you've attached them to my email. So first of all, question 13. In part A, you had to find the coordinate of the intersection of the curve and the straight line. In part B, you need to find the area of shaded area R. So to find the shaded area R, one way of doing it is just simply by working out the integral of the curve above minus the integral of the curve underneath. So it's the difference of these two. So we can have a go at doing method 1. So you always take the one that's on the top, subtract the one that's on the bottom. So it's going to be the integral of the curve above, which is the curve, so it's the quadratic. And you could do minus the integral of the curve underneath. Well, it's not a curve, it's a straight line, but it's because when you integrate between those two limits, so the limits are the same, you are going to obtain two areas and you will subtract them. So you can split it into those two. So this is area under the curve minus area under the line. Okay, so I'm just going to you can actually do it yourself. I'll just do this one integration for you. So when you integrate it, add 1 to the power, divide by that power. So it's x cubed over 3 and then 8x. Remember, integration, nothing disappears. You'll, if anything, you will get an extra c if you don't have limits. This one will go to 10x minus x squared over 2. Okay, so keep the big brackets because you need to sub 9 in. Like I said, I'm not going to do that fully, just do the substitution because you're going to do it with a calculator. So let's do it in curly brackets, minus, and let's put 2 in. So I'm still at this point. And minus, over here we're going to put 9 into this one. Minus, let's put 2 in. And don't forget you've got a function on the calculator that we can check what this integral is by typing it in as it appears. And but this is only for checking purposes. So over here you can just type it in and work out. So I'll let you do that. Okay, alternatively what you could do, you could just work out the area under the curve. You've got no choice but to use the integration. So it's the same as in the previous method. So you do that using the integration minus the area of the trapezium. So work out the area of the trapezium by knowing how to do that. So this is 2 between 2 and 9, which is 7. That length here is the y-coordinate of point B. This length here is the y-coordinate of point A. And this is just the right-angled trapezium. You add the parallel sides together. So that's going to be 8, add 1, multiply it by 7 and divide everything by 2. And that would be the same answers you get by integrating the straight line before. Okay, so let's move on to question 14. So first of all, you are asked to rewrite this equation in that form. So notice what we haven't got tan anymore. So in part A, we are going to use the identity tan 2x is equal to sine 2x over cos 2x to replace tan on the left hand side. So let's go ahead and do that. We don't have any fractions, so let's multiply through it by cos 2x to put it onto the right hand side. You've got 5 sine 2x cos 2x, and move that across onto that side because we want to have 0 on the one side. There you go, and then factorize sine 2x. So I normally, when you factorize, you put sine 2x at the start. They've chosen to put it at the end. So if I do it in front of the bracket, you can do the next line by writing this. So part A is done. For part B, you just need to solve this. What I'm going to do is just find the solutions to this equation by using the fact that this equation and this equation, they will generate the same solutions. They are the same equation. So if I can solve this, this will give me the same solutions. So really, for part B, we need to concentrate on solving this equation. Before I start solving, I need to work out what values of x I'm solving for. So notice we are solving for x being between 0 and 180, but in our question we are dealing with 2 x's. So that means my 2x need to be twice far apart, so from 0 to 360. So I'm going to look for the solution between 0 and 360. Now you've got something that's factorized, it's equal to 0. So two things times together are equal to 0. So it's similar method as you do when solving quadratics. It's either one of them is equal to 0 or the other for the answer to be 0. So you solve two equations. 1 minus 5 cos 2x is 0, or sine 2x is 0. So we've got to solve here, rearrange this to get cos 2x is equal to, that would be 5 cos 2x is 1, so cos 2x is 1 over 5. And then you reach for the calculator. Cos 2x, we are in degrees. So let me just check if I'm in degrees. I think I'm in radians, so I need to change it to degrees. So I'm going to do cos inverse of 1/5. So I'll go shift cos, 0.2 is 1/5. So it's 78.463. Notice I'm not rounding yet because I'm going to divide it by 2, then I'm planning to round it. I'll put even a couple of more digits maybe. Okay, there will be another solution because we are going to find what 2x is from 0 to 360. Give me the answer of 1/5. So if you remember from cos graph, this is 360. So you found one answer here. You always take away from 360 because that's 78.46. So you need to do 360 minus 78.46, blah, 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 so 70. Let's just do 360. Oh, let's take away 360 to give me a negative answer, and then I'll copy the positive. So that will be 281.5369, etc. So now x, you must divide these two answers by 2. Again, I'll let you do that yourself. I'm not going to do that. So divide these by 2 because you're looking. Okay, let's go to question 10. This is actually not on your exam, but since you've asked me to go through that, I will go through this question. So over here, you need to combine the logs. Before you can combine two logs taken away from each other, you've got to get rid of that 2. So that 2, one rule of logs tells you that that 2 can be written as a power. So you've got log base 3 of x squared minus log base 3 of x minus 2 is equal to 2. Now you can combine the two logs. So one rule of logs says if you've got the difference between two logs, you can combine it into a single log of those two values divided by each other, so the quotient. There you go. Then you're going to undo this log. So what is the base? The base is 3. That's the number that's as a base. It's the lowest one in this expression. So it's 3 to the power of 2 gives you this. So x squared over x minus 2 is going to be 3 squared, which is 9. So x squared is 9 multiplied by x minus 2, expanded, rearrange to put it onto one side and solve the quadratic. So again, you can have a go at solving the actual quadratic yourself. Okay, question 8, you've got this, I think it was, I don't know, a pill or something. It was, the volume of that was 16 millimeters cubed. You need to show that, given that the volume is 16 millimeters cubed, the surface area can be expressed in like so. Okay, so first of all, they give you information that the volume, about the volume. So let's remind ourselves of the formula for the volume. So it's the base, which is the circle, so pi x squared in this question, times h. The volume is 60 pi x squared h, so that means h is equal to 60 over pi x squared. Right, the surface area, let's call it A. So the formula for the surface area, imagine it was an empty cylinder. You would have 2 circles and a rectangle. If you cut it along here and slide it open, so that's the surface area. So it consists of 2 circles, so you'll have 2 times pi x squared and a rectangle. The height is h, and the base here of this rectangle, or the length here, is going to be the circumference. Now the circumference is pi times diameter, so pi times 2x, so 2x pi. So the area of that part is simply 2x pi multiplied by h. So we're going to add 2x pi multiplied by h. Now you can see that this expression is beginning to look like what we want to get. We have got 2 pi x squared, so that's good. Just need to make this one look like so. We've got x, we do have x, but we also have h. So we're going to get rid of that h, replace it with that expression 60 over pi x squared. So you'll have 2x pi multiplied by 60 over pi x squared, and you've got 2 pi x squared as well from the previous part. So let's copy that down again. And you just need to tidy this up. Remember, this is just over 1. So this will contribute to the numerator, so that would be, I'll write it on this side here. On the top, on the bottom, you've got pi x squared, pi cancels, x cancels, one of the x's, and you've got 120 over x left, as asked. Okay, to find as soon as they ask you to find the value of x when a is at its minimum, and they've actually told you to use calculus, you need to differentiate. So this is why you worked so hard to obtain this expression in terms of just x. So a is 2 pi x squared plus, let me just prepare this for differentiation. So bring the x to the top and differentiate. So dA dx is, remember, 2 pi is just a constant, it's just a number. It's over 6. So if you had 6x squared, that would go to 2 times 6x. So it's the same here. 2 comes down, multiplied by 2 pi, and reduce the power of x. Do the same here. The power comes down. It becomes minus 1 times 120. So I put minus 120, x to the power of minus 2. So it's 4 pi x minus 120 x to the power minus 2. Whenever you're looking for a minimum or maximum of an expression, so the optimal value, you are going to make the x equal to 0. It's really important to write this down because you get your method mark straight away. So we need to solve this equation. Running out of space. I think I'll just give you a starting point and you can do it yourself. I would rewrite it like so. Equals 0, move it across, then multiply through by x. So you have 4 pi x cubed is equal to 120. I said I will do it. I was going to leave it to you, but I'll do it anyway. So x is equal to cube root of 120 over 4 pi, which you can work out to whatever decimal places you've been asked to. Okay, and now part D is actually really simple. Once you've got this value, you're going to substitute it into this to obtain a value for the area. Okay, so you can you'll do 2 pi times whatever this is squared plus 120 over this again. To show that it is indeed a minimum, you also use calculus. That's the quickest way of doing it. You're going to differentiate again your area. So you've differentiated once and you're looking for the second derivative. So d2a dx squared. So again, remember 4 pi is just a number, so it will go to 4 pi. This time is going to be plus 2 gets times together by 120, 240 x to the power minus 3. And you're going to substitute that x that you found earlier. There you go. And the value you're going to work out will give you positive answer. So you write it down and then you say it's greater than 0, therefore it's the minimum. Think of the greater than 0, it's a smiley face. We are drawing because we are happy. So it shows a minimum over here. If it was negative, in this case it would have been the wrong answer for this question, but that would have shown that it's a maximum. So I believe that's the last question. I think it was a very difficult question, if I remember rightly, when it was asked. Loads of kids couldn't do it. So you actually needed to interpret the text really well, and it doesn't, it helps if you actually draw it for yourself and you didn't have a sketch. So I've sketched it. You were asked previously to find those points, so I found them for you. I think you ticked them as well. Then you had to find the length CD, and then you are told that CDE, so that distance over here, is 3 times CD. So from C to D, I'll redraw it again. That's 3 over 2 root 5. And if you carry on further, for that distance here to be 3 times in CD, this one needs to be twice as long as CD. So I'm going to multiply that by 2. That will give me, there you go, that's what I'm going to, this is your DE. Okay, so this is going to be 3 root 5. Now, you also have this length B to A, and you do know that length B to A, or A to B, is root 80. So really, the best thing to do here is to imagine splitting this. It looks like a kite, really, doesn't it? So, it's not the right angle. Let's see here. 2 triangles. This triangle is on the top, so the triangle ABC. Let's find the area of that. The area of that triangle. Base times height divided by 2. So root 80 multiplied by 3 over 2 root 5 divided by 2. You can work it out. And then we can work out the bottom triangle, which is this one here. The area of ABE is root 80 times the height, which is 3 root 5 over 2, and work it out. But in fact, you didn't need to do all of this for ABE, because if this one is twice as high, the area is going to be twice as big as the first one. So you could have just worked it out like that. But you can find out both of these and then finally add these two together. So this is question 5. I hope that helps.